Recording has started.
The first couple of days, we just went over the basics of the structure of numbers and how our basic operations really work, why things work the way they do in our basic operations. The calculation part of it, of course, is pretty simple. It's really just the number theory behind it. Well, today we want to take the next step, integers. Integers are just the next step from our whole number. For our whole numbers, zero, 1, 2, 3, and counting on up from there. Integers include all of those, and of course the negatives, -1, -2, -3, and so on. With our integers, to calculate with our integers, the first step we need to do is figure out how to represent a number. Talk about how to represent a value graphically. We use the number line. And those lines are evenly spaced. Now, if I want to represent a value like 6 on a number line, I can just put a dot at 6 if I wanted to. And if I'm just representing a bunch of different values, putting dots on the number line is probably the simplest way to do it. But if I want to do something with it, I'm going to calculate with these. There's a better representation, a more mechanical representation. It is called a vector. A vector is just an arrow that starts at 0 and goes to that number. So the vector for 6 looks like that. Now, a vector has two qualities. It has a direction, going positive or negative direction, and it has a length. Technical term for the length is the absolute value. So this vector is going in the positive direction, and it has a length of 6. So it has an absolute value of 6. This green vector is going in the negative direction, but it also has an absolute value of 6 because it has a length of 6. So I put that vector out there. That vector, of course, has a length of, what does that vector represent? 2. Positive, and it has a length of 2, or an absolute value of 2. If I want to represent 6 plus 2. The way we mechanically do that is we take the vectors for 6 and 2 and we put them together. So I'm going to move the vector for 2 here. Put it on the end of the vector for 6. And of course, we didn't have to do the vectors to know that 6 plus 2 equals what? 8. Very good. 6 plus 2 equals 8. We knew that without drawing it out. But the vectors illustrate that concept. Well, with positive numbers or whole numbers, we don't need the vector diagram to make it work. But what if I had 6 plus a negative 2? We have an integer in there. The vector for negative 2 looks like this. To add 6 plus negative 2, I'm going to take that vector. I'm going to move it over to the 6 and put them head to tail. And I see that that comes out at 4. Six plus negative 2 equals 4. I don't expect you to draw out number lines every time you add integers. Dealing with negative numbers, that'd be a lot of drawing. But I keep that picture in my mind as I'm working with integers. So I might have negative 42 plus 27. What I am picturing in my mind is this. Here's 0. Negative 42 goes in the negative direction. Now I start at the head of that negative 42. Where it ended is where I start the next number. 27 is positive, so it goes the opposite direction. Its absolute value is smaller. It's a shorter vector, which means it stops before it gets to 0. So this picture is telling me two things. First, I ended on the negative side of 0, so my answer is negative. The second thing it tells me is that my vectors go in opposite directions, which means the value of my answer here is the difference in their absolute values, or the difference in their lengths. So I can do 42 minus 27, it's just 15. So my result is a negative 15. I might have a negative 38 plus a negative 54. So again, I picture a 0. Negative 38 goes in the negative direction. Well, negative 54 also goes in the negative direction. So again, this picture tells me two things. My answer is obviously on the negative side, since everything's going in the negative direction. My answer is negative. And since the vectors point in the same direction, the size of my answer, the absolute value of my answer, is combining the lengths of those vectors, or adding their absolute values. 38 plus 54, 92. So that's a negative 92. So the vectors, if they go in the same direction, add their absolute values. If they go in opposite directions, we subtract or find the difference of their absolute values. I have 53 plus a negative 29. Here's 0. 53 is positive, so it goes in that direction. Negative 29 is negative, so it goes the opposite direction. Is it shorter or longer? Shorter. It is shorter, so it stops before it gets back to 0. That tells us my answer here is positive, because I ended on the positive side of 0. Do I add the absolute values or subtract them? Vectors go in the same direction or different? They go different directions, good. Since they go different directions, we have to subtract the absolute values. 53 minus 29, which is 4. So this is a positive 24. I might have 47 minus a negative 63. Here's 0. Positive 47 goes this way. Negative 63, same direction or opposite direction? Opposite. Opposite direction. Longer or shorter? Longer. Longer. So it goes past 0. So that's telling us our answer here is negative because it went across to the negative side of 0. Values are subtracted. Subtract. Let's go in opposite direction. So 63 is the bigger one, minus 47. It is going to give us 16, negative 16. I have a negative 42 plus 73. Here's 0. Negative 42 goes in the negative direction. 73, same direction or opposite? Opposite. Opposite direction.
Opposite.
Well, it goes past 0. So that is telling us we've passed 0, so we've gone to the positive side. So our answer is positive. And do we add the absolute values or subtract them? Right. Subtract them. So the bigger one's 73. Subtract 42, that gives us a 31. That's a positive 31. So again, that picture of the vectors helps us decide, is the answer positive or negative? And do we add the values or subtract the values? Fraction. Fraction. Let's look at 8 minus 3. minus 3 up there, and I asked you guys to use, most people would have come up with a picture, something like this. Start at 0, go to 8, come back 3 to 5. We all knew that 8 minus 3 was 5, right? Didn't need a number line to tell us that. Simple enough. But if I look at this picture here, it looks suspiciously like a picture for 8 plus a negative 3. Because it is. It's the same problem, same picture. Remember we mentioned on Monday that subtraction is not its own operation. It's part of addition. They actually call them an inverse pair. Addition is the operation, subtraction is its inverse. Subtraction is defined as part of addition. So whenever we see this symbol, there's two things. It operates on the number that actually comes after it. So the subtraction there operates on the 3. And the definition of that symbol is to add the opposite. So when we see that, the negative operates on the 3, so it doesn't change the 8. Adding the opposite of 3. What's the opposite of 3? 3. So that is literally 8 plus negative 3. Now in a problem like this, I wouldn't change it because I can do 8 minus 3 really easily, and I know that answer. So there's no point in changing that one when both the numbers are positive. If I have something like 7 minus 12, that one maybe. Many people can look at that and see that 7 minus 12 is just what? Negative 5.
Negative 5.
But you might want to look at it and say, well, that subtraction operates on the 12. 7 doesn't change. That becomes plus the opposite of 12, or plus a negative 12. And now, once it's addition, we can use those factors. We've got positive 7. Negative 12, of course, is the opposite direction and a little bit longer. You can see it comes up to negative 5. So like I said, most of us can do this one without changing it. But if you struggle with it, change it to addition, and then you can just use that vector representation. When we get to one like this is where changing it to addition, adding the opposite helps. Because negative 43 minus 28 is difficult for a lot of people to do. So that subtraction operates on the number that comes after. So that operates on the 28 here. So negative 43 does not change. Subtracting 28 becomes adding the opposite of 28. So we add, what's the opposite of 28? Negative 28. So now we can do our vectors. So 0, negative 43 goes this way. Well, negative 28 goes the same direction. Our answer is negative. Add the absolute values. Negative 7, 1. One that tends to confuse people is this number. 32 minus a negative 54. Now again, the subtraction operates on the number after it. So the 32 does not change. Subtracting a negative 54 becomes adding the opposite of negative 54. Add, you have to add, what's the opposite of negative 54? 54. Positive 54 or just 54. So we don't need the vectors for this one. Now it's just 32 plus 54 is 86. Might have negative 53 minus a negative. Now again, it's on the number that comes after it. So here it operates on the negative 29. So our negative 53 does not change. Subtracting a negative 29, adding the opposite of negative 29, which would be positive 29. Now here we might want the vectors. We've got 0, we've got negative 53. 29 goes the opposite direction, but it's shorter. So there is positive or negative. Add or subtract the values. Correct, because the vectors go opposite directions. 53 minus 29, 24. Get a negative 24. Any questions there? We looked at multiplication yesterday. We brought up the definition of multiplication. We said 5 times 3 is saying you take 3 5s and add them together. 5 plus 5 plus 5. 3 of those 5s added together. You're repeating the 5 3 times. So with that definition of multiplication, our multiplying by a negative or multiplying with negatives makes sense. Negative 5 times 3, that's just saying take negative 5 and repeat it 3 times, or add 3 of them together. Negative 5 plus negative 5 plus negative 5. All negative 5 plus negative 5 plus negative 5 is just a negative 15. Now, most of us knew before, because we've been taught, that a negative times a positive is a negative, and then you just multiply the numbers. 5 times 3 is 15. But that's why. What if we are given 5 times a negative 3? Well, I can't take a 5 and repeat it a negative number of times. I can't take 5 and add negative 3 of them together. It doesn't work. But multiplication is what we call commutative. What does that mean? Well, that means 3 times 7 is equivalent to 7 times 3. I can change the order of the numbers. So 5 times negative 3 can be changed to negative 3 times 5. That's saying take negative 3 and repeat it 5 times, or add 5 of them together. If I have 5 negative 3's added together, I get 15 again. Again, most of us knew that a positive times a negative gave us a negative. 5 times 3 is 15, so it's negative 15. One that's confusing, though, we've all memorized the rule for it, but the reason why, kind of fuzzy. Negative 5 times 3. I cannot take a negative 5 and repeat it negative 3 times. I can't repeat it a negative number of times. It does not help to switch the order. If I do a negative 3 times negative 5, I cannot take negative 3 and repeat it negative 5 times.
I think you can, because you're a math teacher. But
well, we'll make it work. But the definition of multiplication does not apply here, because we can't repeat something a negative number of times. Of course, we all know, we've all been taught that that has to be what? Positive. So it's going to be a positive 15. We were all taught a negative times a negative is a positive. So you just multiply the numbers and make it positive. 5 times 3 is 15. Question becomes, why? Well, because it fits a pattern. This happens a lot in math where the basic definition that we're working with breaks down. It doesn't work. So what we do is we look at related problems or similar problems that do work in the basic definition, and we try to establish a pattern with those problems. And then we define the answer to the undefined problem to be whatever makes that pattern work. So if I start to establish this pattern, I'm going to start with negative 5. I'm going to multiply it by numbers that we can do. Well, we already did a positive 3. Negative 5 times positive 3 is a negative 15. Now I'm going to change that problem in such a way that it eventually gets me to the problem I'm trying to solve. And here's what I'm going to do. I'm going to take my negative 5, and instead of multiplying by 3, I'm going to reduce that by 1. 3 minus 1 is 2, so I'm going to multiply by 2. What's negative 5 times 2? Negative 10. Now I'm going to continue that. Negative 5 times, if I reduce that by 1 again, I'm going to multiply by 1, which is negative 5. Now let's look at our pattern. I kept the -5 each time, and I reduced this number here that I'm multiplying by 1. My result got bigger by 5 each time. I went from -15 up to -10, from -10 up to -5. Let's see if that pattern holds if I go one more step. I start with the -5 again. What's 1 minus 1? 0. And of course, anything times 0 is 0. So we reduced this by 1 again, and this answer got larger by 5 again. So the pattern continued. So we're going to assume that pattern keeps continuing. If I do 5 times a -1, I reduced that by 1 again. 0 minus 1 gave me the -1. I have to add 5 here. What's 0 plus 5? Positive 5, just 5. I have -5 again. If I reduce -1 by 1, I end up with -2. And of course, I have to increase my answer by 5. So 5 plus 5 is 10. That brings me to the problem I was trying to solve. -5 times -3 would be positive 15. So the reason why a negative gives us a positive is because it fits the pattern. Definition of multiplication, we can't do that problem under the definition of multiplication. So we follow a pattern and we just define it to equal whatever makes that pattern continue. Now I realize for most of us, we're still just going to memorize those rules that we've seen. So if I have 7 times a -6, the answer going to be positive or negative? Negative. We have a positive times a negative, that's a negative. What's 7 times 6? 42. Good. -8 times -5. Positive or negative? Positive. A negative times another negative, we just saw, positive. Times 5 is 40. -3 times 7 gives us negative 21. Good. A negative times a positive is a negative. 3 times 7 is 21. And positive 30. Positive times a positive is always fine. Do division. Remember, we said that their numbers come in inverse pairs. Addition and subtraction were an inverse pair, which meant subtraction was defined in terms of addition. Well, multiplication and division are another inverse pair. So division is defined as part of multiplication. Let me show you. 18 divided by 3 equals blank. It's defined by a related multiplication problem. Like this. We almost work backwards. Blank times the 3 equals 18. In other words, what number times 3 equals 18? 6. 18 divided by 3 equals 6 because 6 times 3 equals 18. Now we also did yesterday define division in terms of subtraction. 18 divided by 3 equals 6 because we can subtract 3 from 18 6 times, right? That's how we were able to turn it into multiplication and repeated addition. But this definition then allows us to analyze how the negatives work in our division. I have a -32 divided by 8. Well, let's look at the related multiplication problem. It's going to be blank times 8 equals -32. Well, to get a negative number, to get a negative result in multiplication, I need a positive number and a negative number. Right now, the 8 is positive, so this one has to be negative. And of course, what number times 8 is 32? 4. So So 32 divided by, or negative 32 divided by 8 has to be a negative 4. (42) divided by negative 6. Well, again, we're going to look at the related multiplication problem. Blank times negative 6 equals 42. Well, for the result of a multiplication problem to be positive, we either need both numbers to be positive or both numbers to be negative. This one, negative 6, is already negative, so this number has to be negative. Well, what times 6 is 42? 7. So negative 7 times negative 6, 42. So 42 divided by negative 6 is a negative 7. And of course, 28 divided by, negative 28 divided by negative 7. A related multiplication problem. What number times negative 7? 8. Well, in order to get a negative result in a multiplication problem again, we need one positive and one negative. The negative 7 is negative, so this number has to be positive. What times 7 is 28? 4. Positive 4 times negative 7 is negative 28. So negative 28 divided by negative 7 is a positive 4. Now you can see the reasoning is a little bit different, but the resulting pattern is the same as it was for multiplication. If I divide positive by or negative by a positive, I get a negative. Or if I divide a positive by a negative, I get a negative. In other words, if I divide one of each, one positive, one negative, no matter what the order, I get a negative result. If I divide a negative by another negative, I get a positive. Just like I do when I combine them with multiplication. Well, we had mentioned inverse pairs of operation. Addition and subtraction are one of our inverse pairs. The subtraction is part of the addition. We had multiplication and division. Inverse pair, because division we just saw is defined as a related multiplication problem or an inverse of multiplication. There's another pair of operations. Powers and roots. Together, they're often just called exponents. I have something like 8. First of all, how do you pronounce that? 8 to the power of 3 or 8 to the third power. What does it mean? 8 times 8 times 8. 3 8s multiplied together. Just like multiplication is repeated addition, a power is repeated multiplication. 8 times 8 times 8 is 512. That one wouldn't be so bad to punch in your calculator, 8 times 8 times 8. But if I give you 2 to the power of 11, we don't want to be trying to punch that in and count. 2 times 2 times 2, did I do it 10 times or 11 times, or where am I at? So first, we need to figure out what button on our calculator helps us do this. Calculator has one of a couple buttons. Mine has this one right here called the caret key. Most of the newer calculators and most of the graphing calculators, that's what they have. You might have a button that looks like this, x to the power of y, or y to the x, one of the two. Or some calculators just have boxes instead of the x and y like that. All of those buttons work exactly the same way. You would type 2, press the button, and then type in the 11. Should give you 2048, correct? Now this exponent has two parts. This part down here, the 2, is called the base of the exponent. It's the number that's being acted upon. This up here, the 11, is called the power. A root, then, is the opposite or the inverse of an exponent. Said 8 to the power of 3 equals 512. Well, to reverse that, we would use what's called the third root. Now, in the root has 2 parts as well. Here, the 512 is called the base of the root. That's the number being acted upon again. 3 here is not called a power, it's called an index. It's related to the power, though, because as you can see, that 3 is the power that we are inverting or reversing, undoing, whatever. So 3, the third root of 512, is really asking us what number to the power of 3, 12. And of course, we saw up here that that number is 8. Third root of 512 is 8 because 8 to the third power is 512. Fifth root of 3,125, that's asking us what number to the power of 5 equals 1,125. Well, it's going to be 5 to the 5th power. How would we get that on our calculator? I mean, I suppose we could take numbers and punch it into the 5th power and see where it's at. If it's bigger than 3,125, we try a smaller number or whatever. Guess and check, by the way, is a valid problem-solving technique. You pick a number like 7 and do it to the power of 5. You get 16,000. Well, that's way too big, so you know it's smaller than 7. Okay? 6, still too big. 5, there you've got it. But that's time-consuming, especially if we were way off on our first guess. So most of your calculators have a key that's either an X root or an N root key. So to do the 5th root, this is an index of 5. We would enter the 5. Now on my calculator, that key is not on the keyboard, it's in a menu. So I have to go in here to the math menu to get it. So 5th, then my X root of 1,125, and I hit enter, and there it is. It gives me the 5. For this class, we're not going to be doing a lot with roots that are bigger than a square root. If we see that radical symbol, it's called, with no number here, that number is assumed to be 2. It means what number squared equals 49? Most of us know that is 7. What is negative 5 squared? Yeah, it's just negative 5 times negative 5. Negative times a negative is a positive. 5 times 5 is 25. Well, on the calculator, if we're not careful, especially on the Texas Instruments, this is one of the things the Texas Instruments you got to be careful with. I try to do negative 5 squared. I enter negative 5 and then hit my X squared key. It's going to tell me that it's negative 25. Well, that's because the calculator does a strict order of operations. Something we're going to talk about tomorrow is order of operations. And a power actually happens before a negative. So the calculator, if I enter it like this, it squares the 5 and then applies the negative. So to square a negative number like a negative 5, I have to put the negative 5 in my calculator in parentheses. Then do the square, and now it'll correctly tell me that it's 25. So now with that in mind, what's the square root of 25? There we go. 5 squared is 25, but Negative 5 squared is also 25, so either one of those is a solution. Now, for what we do, we're going to be looking for real life answers. Most of the time, that's going to be the positive number. We're not really going to be concerned about that negative possible result, but be aware that it is there. There's a possible negative. Okay, as promised, we get a little bit of work time at the end of class. There are quite a few pages here to deal with the integers. So in the book, page 111, the problems 1 through 39, the odds. Page 114, 1 through 35, the odds. And page 160, 1 through 39, and 51 through 79. Now, as I mentioned before, I don't collect the homework. I'm not going to grade it. So homework is there to help you practice the material. For each of these, there's a lot of problems there. I realize there's about 80 problems there. Actually, closer to 95 problems. But as you're going through this material, and the first couple seem easy, feel free to skip ahead to the more difficult ones. Big thing is make sure if there are word problems, like these are the 51 through 79, I believe are word problems. If there are any word problems, make sure you do at least a couple of those to make sure you're able to work with it. The reason is when we get to quizzes, that's where students struggle is the word problem. Being able to gather the information out. Do you have any questions? Okay, so like I said, the last 10 minutes here, you have to get started on the homework if you want. I will be on the network to answer any questions if you have them. Otherwise, if you're